Morning, everybody. Welcome to a very bright and fresh Mella. The sun rising over the hills. We're well away from the traffic. And on a crisp morning like we've got here at the moment in mid-December as it now is, it's perhaps difficult to comprehend that what you see outside is a changing landscape. A landscape that's perhaps changing more rapidly than ever before. And my job this morning really is to introduce the Storm Project, very briefly give you an overview. And the Storm Project is at its very heart about managing change, and it's about managing change in a very, very particular way, and that is managing change regarding climate change. And we're not going to be talking about whose fault climate change is. What we're talking here today about is dealing with the reality of change itself. Now, I should say right at the beginning that the Storm Project is a multi-partner project. It's funded by the Horizon 2020 project through the EU, and we have over 20 partners, some of whom are represented on the programme here this morning, and it is a genuine partnership project and could not take place without all our partners working together. And although, as you will see very shortly when I give you an overview of the project, that we have some fantastic sites we are looking at, the point of the project is not to go and look at those sites as such. The point is to think about how we can manage that changing climatic environment where it impacts on heritage, what it means for heritage, what it means for the owners and users of heritage sites, and also the people who manage those sites. And this is about thinking, how can we maintain those heritage sites into the future, and how can we help people to still enjoy them, and perhaps also engage with members of the public like yourself in helping the owners and managers of heritage sites actually to chart that change and put in place long-term and short-term strategies that will help us safeguard heritage from all sorts of aspects of climate change itself. So, the Storm Project. Yes, we have some nice logos, as you can see. The point about Storm is that it's about collaboration and it's about knowledge sharing. This is the heart of the Storm Project. So in many ways, we're not generating new information about climate change and its impact on heritage. What we're trying to do is come up with strategies for managing those changes. And in part, that's using innovative techniques for monitoring cultural heritage, but also using established techniques in new combinations and new ways that hopefully, at the end of this project, we will be able to present as a package that managers, owners and users of heritage sites can plug into and use to help them and us manage those changes. So it's meant to be a very, very practical research project. Research and practicality doesn't always go together, but with Storm, that's absolutely crucial. Now, in order to develop these risk management packages, we have 5 pilot sites across Europe. We have the Diocletian Baths in Italy, we have the Greco-Roman temple at Ephesus in Turkey, we have the historical centre of Rhydymno on Crete in Greece, in the Aegean, we have the Roman ruins at Troia in Portugal, and we have Mella here in the UK. Each of these sites has slightly different problems when it comes to dealing with climate change and its impact on heritage. Each of these sites is a slightly different period, slightly different range of archaeology and heritage. So we have built heritage, which survives quite extensively on a number of these sites, particularly at Ephesus in Turkey, the Baths of Diocletian and Rhydymno on Crete. We have lots and lots of below ground archaeology at Mella and at Troia, as well as those other sites. And we have a range of periods. So we have Roman, we have medieval, we have post-medieval and industrial, and we have prehistoric sites. So the point about these 5 pilot sites is that they span the range of archaeology that we have in Europe, both in terms of chronology and topographical location. So we have Mediterranean sites, we have Atlantic sites, and we have Northern European upland sites. As you would anticipate, each of those pilot sites has a different set of needs when it comes to coping with climate change and its impact on heritage. And the first part of the project was focused on identifying what those needs were and what the threats were. So, Baths of Diocletian, which I'm sure many of you will be aware of, which goes back to the 4th century AD, towards the end of the Roman Empire, at least the Western Roman Empire, and has been constantly reused since then, is now one of the National Roman Museums in Italy. It houses a very important and large collection of Roman artefacts, as well as having the buildings themselves from the 4th century AD, and it's got a charter house, a monastic establishment built into part of it that was designed by Michelangelo, plus there's a Baroque church using another part of the site. So it's a very complex site which includes objects and structures dedicated to that site, but also has material housed in it as a museum. So there's some very specific needs for that site. So what the owners of that site have identified is that there's an increased risk of storms and strong winds. There are increasing temperature extremes and humidity cycles in Rome, risk of biological infection and increasing risk of air pollution as well. And as you will see on this slide, we've divided the hazards into slow onset and sudden onset hazards. So sudden onset hazards are what we might call dramatic events. Strong winds and storms, for instance, fires, perhaps large amounts of snow, flooding, those kind of things. Those are events that happen over a very short time. Whereas we have slow hazards, those insidious hazards, like biological infestation, like erosion, perhaps damp due to changing water tables, air pollution, humidity, and of course we mustn't forget human activity, which can be altered and changed by climate change itself. So at the Baths of Diocletian, those are the sort of main areas of hazard and topics that need managing. And it was at the Baths of Diocletian that we first sort of started to establish these concepts, and we then went on to apply them to the other 4 pilot sites. So at Rivimno on Crete, the Forteza fortress and the historical centre of the medieval and post-medieval town. We have a coastal site, which you can see here with some fantastic late medieval castle walls with lots of standing buildings and lots of below ground archaeology. So here we have more an emphasis on slow hazards from climate change, humidity, biological infestation, erosion, but in particular identifying short, sharp hazard events, sudden events that include heavy rainfall and drying that might lead to an increased risk of fire. Ephesus, which is at the eastern end of the Mediterranean on the western seaboard of Turkey, which is not an occupied site. So the first 2 pilot sites I've just mentioned are actually living, functioning cities, towns and cities. Ephesus is perhaps more your classical archaeological heritage site, a ruin, not very far from habitation of course, but nevertheless largely a ruined landscape. That has its own unique set of problems. It was a coastal site due to coastal silting. It is now inland. That in itself, as a sort of climate change, impact of climate change case study, is very interesting. It's one of the reasons why Ephesus declines as a port and town. It was at the western end of the Silk Road in the Greek and Roman period, so it was a major trading port and onward shipment centre. So once the harbour had filled in, that really meant the end for Ephesus. But we're interested in the changing environment here in the early 21st century. So although there's a risk of sudden hazards from environmental change around drying and leading to wildfires, which might impact on the Roman and Greek remains. It's really the slow onset hazards here at Ephesus that is one of the key issues for this particular site, particularly changes in the water table, erosion from changes in weather pattern. Again, we've got biological colonisation as the climate changes, different forms of vegetation and mould are encouraged. And then we've got the humidity cycle as well. So this is very much around managing one particular part of the Ephesus site. So we chose the theatre here, which you can see on the slide, as the case study in amongst the many hectares of ruins at Ephesus. If we move to the other end of the Mediterranean, we've got the Roman ruins at Troia on the west coast of Portugal, just south of Lisbon, where we have a peninsula which in the Roman period, throughout the Roman period, was used for the the salting and manufacturing of fish products. And here we have a whole sequence of Roman factories producing those salted products. And here we have some very particular sets of threats from climate change, especially in terms of sudden onset threats. We have storms and heavy rain, but we also have the threat of tsunamis and high tides and strong winds whipping up sand as well as the seas. So Troia has some unique problems when it comes to climate change and threats because of its coastal location facing the Atlantic. It also has those very familiar slow hazards that quite often can get overlooked if we don't manage them properly. So the changes in the humidity cycle, the changes in the kind of biological flora and fauna, as well as general erosion, and of course managing human intervention on the site, which may or may not be facilitated by the general change in climate change. There's a particular problem at Troia with particulates that are wind-driven in the air, because Troia, although there's a lot of below-ground archaeology, there's quite a lot of standing buildings. And the wind can whip up those particulates, and they can actually damage the plasterwork and the frescoes that survive on many of these buildings at Troia. So again, we have a unique particular part of the heritage resource that we can look at Troia from in terms of the threat of climate change and what it would do to the winds and the humidity cycle. And then we come to Mela. Now, my colleague Rob Williamson will talk in more detail about the Mela site. What I would say here is that Mela is a North European site. It's an upland landscape site, and it's a site where we have prehistoric, Iron Age Roman and industrial sites. So again, because we've chosen the 5 pilot sites to represent the archaeology of Europe through the prehistory to the industrial period, Mela has a particular role in demonstrating the prehistoric side and the industrial side. We at Mela have particular problems around storms, heavy rain, snow, but also wildfires because of drying. And Mela, we've identified that we've got those familiar problems of humidity changes and biological colonisation, but we've also got some specific problems around drought and freeze-thaw action, which I'm sure Rob will mention in a bit more detail later on. For those of you not familiar with the Mela site, because we have 3 archaeological sites we're looking at, we're actually looking at a Bronze Age cairn up on Mela Moor, so that's dating to about 4,000 years ago. We have an Iron Age and Roman hilltop settlement, which we are sitting in the middle of at the moment, which runs from about 400 BC to about 400 AD. And then down in the valley, we have a water-powered cotton spinning textile mill built in the 1790s, but down at the end of the 19th century, representing the industrial side of the story of humans in Europe. Having chosen the pilot sites, what the project next did was to ask the owners and managers of those sites for their requirements as to what they would think in terms of how heritage is going to be affected by climate change. And also we asked them about what their systems already were when it came to dealing with climate change and heritage. And you can see here we've got the priorities of the pilot sites as identified, and then we've mapped them across to the project outcomes. So for this morning, I just want to sort of focus on those 6 priorities which the pilot sites themselves identified. Remember, the pilot sites represent the owners and managers and users of heritage sites. So we're very keen to look at what their needs were so that the project could design management tools that were practical and usable by not just our pilot sites, but hopefully by other people owning, managing, using heritage sites. So you can see monitoring and prediction of hazards was important. Disaster warning, disaster planning, conservation training, closer liaison with emergency services, and collaboration with other cultural heritage bodies were all priorities for our 5 pilot sites. Now, just because they're priorities doesn't mean that each of our 5 pilot sites have sufficient knowledge and experience in all of these areas, which of course is part of the reason that the STORM project is being undertaken. So mapping those priorities against the STORM outcomes, it has been a vital part of the project so that we can come up with systems that help owners of heritage sites access ways in which they can monitor and predict the impact of climate change on their sites, help them to come up with disaster warning and disaster planning, and also access conservation training, and raise awareness about better liaison with emergency service and the relevant cultural heritage bodies. Just to sort of briefly show you some of the impacts of slow and onset hazards, these are some of the potential impacts of onset hazards. These are actually examples from the Roman salting sites at Troia in Portugal. You can see that sudden weather events have a particular effect on standing structures, which can undermine them and erode them. But then we have the more insidious, slow onset events as a result of climate change, whether that be coastal erosion, salinisation from changes to the water table by the coast, increases or decreases of rainfall, wind and humidity, cycles and changes. So in fact here you can see a range of impacts on this slide from those slower onset hazards. I think it's very easy to cope with sudden events, a sudden crisis, and a lot of disaster planning has historically in Europe been focused on those sudden events and dealing with those sudden events and dealing with remedial work on heritage and archaeological sites. Thinking about slower onset hazards takes more forethought, and quite often owners and managers of sites need to be reminded that this is as important as having an immediate disaster plan for a sudden fire or a sudden flood. So this is a crucial part. This is half of what the project is doing. Thinking about future planning and mitigating against these longer term changes in terms of climate change and heritage, where it impacts at a lesser and a greater extent. Again, Rob's going to talk a bit more about the management systems we've been designing, both the online management systems and the structures behind that. This is a very early example from last year of how we were trying to map out the actual technical management processes, which is leading into an online management tool with a dashboard that will enable owners and users of heritage sites to have all the information in one place, where you can look at those indicators, those monitors for long and short-term changes which are as a result of climate change in any particular given area. And you will have a chance to see some of the on-the-ground monitors this afternoon when we go out to our 2 sites here at Nevell. Nevell is, as I say, is one of 5 pilot sites. Each of the 5 pilot sites have some common sensors that we're using, but each of the pilot sites also has a unique set of sensors that they've developed and used and trialled and tested. Because one of the things about the Storm project is to experiment with the sensors, to see what works and see what doesn't work, to see what's feasible and practicable when putting together this package of sensors and this online app that allows owners and users of heritage sites to make informed decisions and choices about how they should manage their own site as the climate changes. So the vision for Storm, the vision we set out with 2.5 years ago now, so we've got about 5 or 6 months of the project left, was to use predictive models of climate change, to come up with monitoring tools for slow and sudden onset hazards, to review and promote methods for quick restoration and long-term conservation. Above all, to collaborate through our networks, through the project, the 20+ project partners, through our stakeholders. We have a group of stakeholders in each of the 5 pilot site countries and beyond, and also to think about that online media platform, how that might help collaboration as well, and come up with training packages. We've been trialling training packages. We have a Storm Academy that we've set up as a way of training people about the Storm concepts and leading into the legacy of the project, and also to influence policy, to hopefully come up with individual policy improvements at a European level and at an individual nation-state level as well. And that's something I will come back to at the end of the morning, at least from a UK point of view. Climate change happens. The climate always changes. It might change at a faster rate or a slower rate. And the impact of climate change can be very, very dramatic. And we had a very good example of that here at Nevell in June, July, August and September, when because of a prolonged period of dry weather, running back over months and months and months, all the blanket peat you can see on the moors around us were dried out, and we had massive peat fires for months and months and months surrounding the Nevell site here. This is a NASA aerial photograph taken from a satellite you can see on the 3rd of July. That is smoke billowing across the landscape just a few kilometres from where we're standing now. And you're actually seeing there hot spots, that's fires in the peat, over an area of as much as 10 square kilometres. That is a sudden onset event as a direct result of changing weather patterns. And it actually impacted here on Nevell because of the smoke. That kind of thing is very dramatic and very visual. What this project is trying to do is to take the management of those kind of serious sudden events and match them with a longer term planning strategy to allow sites like Nevell or Troia or the Baths of Diocletian or Rhydymno or Ephesus to cope with both these sudden events and these longer term problems in terms of climate change as our climate evolves, particularly over the next 50 years. So sit back, enjoy the morning. We are going to work you in the afternoon because we're going to get you outside. I'm hoping the weather will stay fine. Think about both those sudden and onset hazards as we see a variety of presentations this morning from a number of different points of view, particularly not just based in the UK, but Ireland, and from our Storm partners as well. And think about those issues of what the climate change really means for heritage and how we enjoy our heritage as well, and how we can save our own archaeology and heritage for future generations. Thank you.
One of the generally accepted effects of climate change is rising sea levels.
Rising sea levels is one of the metrics we've identified, and we do have monitoring systems in place. It's as we will hear, it's a particular issue for Troia because it's a peninsula facing the Atlantic. So it is there in the project.
Are we recording these sites to a great extent so that when they disappear, which they might in the future, we've got records?
Straightforward answer is yes, and I'm not just talking here about the 5 pilot sites for Storm itself. We'll hear from the Cherish project later on this morning, which is a Welsh-Irish Republic project where they're actively recording sites that are being eroded as a result of coastal change and the impacts of storms and undoubtedly sea level change. So yes, there are schemes in place to record archaeology and heritage where it is threatened. There's a particular emphasis in the UK and Ireland, as you would expect, on coastal erosion, because that's where the changes are most acute. But as I think David Knight will mention, that we've also got issues around flooding in river valleys as well. So there are schemes to record these sites, yes, but ultimately there are so many sites to record, we do have to sit back and think about how we manage that recording process efficiently, how we get those skills in recording out to as many people as possible. And that's part of the thinking behind some of the training and management systems we've been developing on Storm.